All right, you guys, this is page 14 in your binder, or not binder, the packet. And we're going to talk about, finally, we're going to talk about the shortcut that I've been talking about. Okay, so this basically, a lot of the derivatives we are going to do have rules that we can use that save us all that time of going through the limit process every single time. All right, so the first rule we're going to learn is called the power rule. All right, and the power rule looks like this. It says that if you have a function that equals x to some power, all right, so these are really all for polynomials, okay? So when you have that function there, that is x to some power, then the derivative, so f prime of x, is equal to, well, we take that exponent and bring it down in front. So the n is multiplied in front times x to the, and then we subtract 1 from the exponent. Okay, we'll see an example down there, and once you see how it works, it's very doable. A couple little facts that this leads to is that the derivative of a constant is just 0. And that should make sense if you think about what the graph of a constant looks like. All right, so if I have a little xy axis here, and I were to graph a constant function, it's horizontal, and the slope of a horizontal line is 0. So the derivative of a constant function is 0. Another fact that we get is that the derivative of a linear function is constant. What does that mean? Well, same idea, like if we drew a little sketch of a graph, right, and this time we're going to be linear but not horizontal, that slope is constant. It's not changing. So like if this were the line y equals 3x plus 1, the slope we know is 3, which is a constant. All right, so let's do some examples here. Each problem says find f prime of x. All right, that notation, remember, means the derivative. So in number 1, I'm going to go f prime of x equals, well, this is just a constant, 3. Right, and so the derivative of a constant is always 0. So the answer there is 0. Number 2, f of x equals 2x. That's linear. So the derivative, f prime of x, is just going to equal 2. So whenever you have a linear term like that, where it's just something times x, then the something, the coefficient, is your derivative. Right? So again, remember the derivative represents the slope of the tangent line. So in number 1, the slope is 0. In number 2, the slope is 2. Let's take a look at number 3. F of x equals 4x squared. All right, here's our first real chance to use the power rule. So I'm going to do f prime of x and equals, the exponent on top, 2, gets moved in front. So now it's 2 times 4, x to the, and then I subtract 1 from the exponent. So 2 minus 1 is 1. So x to the first. But really that's just 8, x to the first. And usually when we do these, we'll do that multiplication in our head. So you don't need to write out 2 times 4. You'll bring that 2 down in front and say 2 times 4 is 8 right away. Okay? You also don't need to write the 1 as the exponent, but you can. So the derivative of number 3 is just 8x. All right, look at number 4. It's got a bunch of terms. The great part about power rules, we can do it one term at a time. So as I take the derivative, if I'm trying to find f prime of x, the derivative, one term at a time, I do power rule. So for the first term here, I take that 4 and I'm going to bring it in front. 4 times 3 would be 12 x, and then I subtract 1 from the exponent to the third. And I do plus, and I go do the next term. 2 times 5 is 10 x to the first, because I subtracted 1 from the exponent. And then I have minus 2x, so the derivative is just 2. And minus 7, the derivative of that is 0. I'm not going to write plus 0, so there's my answer. All right, now a problem like number 5 gets a little more interesting. So 5 right now doesn't look like something I could use the power rule with, but if I get creative with my exponent rules, I'm going to rewrite 1 over x as x to the negative first. And now I can use the power rule. So I would say f prime of x equals, well, I bring negative 1 in front, so now it's negative x, and I subtract 1. So negative 1 becomes negative 2 since I subtracted 1. Now we're not going to leave a negative exponent in there, so I'm going to make this negative 1 over x squared, and that's my derivative. Number 6 will do a similar way. It doesn't look like power rule right now, but I can change x to, or square root of x to be x to the 1/2 power. And now I can use power rule. F prime of x equals, bring the exponent in front, 1/2, x to the, and subtract 1. 1/2 minus 1 would be negative 1/2 is my new exponent. Okay, so here I've got to bring that x to the negative 1/2 into the denominator. So now I get 1 over 2 x to the 1/2. And I can kind of, the original problem was in a square root form, so I'll bring this back to 1 over 2 root x. And that's the derivative there. All right, let's finish up this page here. So 7 and 8. Number 7 says find the equation of the tangent line. All right, we worked on that the other day a little bit. For the equation of the tangent line, remember I'm going to need a slope. I'm going to need slope. And I need a point. Okay, well, the slope comes from the derivative, so I'm going to try to find f prime of x. Well, look, this is just the same problem as 6. So I already know the derivative is going to be 1 over 2 root x. All right, and at x equals 4, I can plug in 4 to find f prime of 4, which equals 1 over 2 root 4, which is 1 over 2 times 2, so it's 1 over 4. So I now know my slope equals 1/4. Then to find the point, I know it's going to be 1 comma, nope, that's not right. It's not 1, it's 4. 4 comma, and then I'm plugging into the original to find the point. So I'll go f of 4 equals square root of 4 equals 2. So my point is 4 comma 2. And now I have all my information for the tangent line. So we'll go y minus 2 equals 1/4 x minus 4. Okay, and finally, number 8. Find the points on the curve where the tangent is horizontal. So let's go with, if it's going to be horizontal, all right, I know I'm going to get a line that looks like this. All right, so that means I'm looking for m to be 0, the slope, or better yet, the derivative to be 0. I want to know when is the derivative 0. So let's solve this. F prime of x equals, I'm going to take the derivative. Power rule, bring the 3 in front, so 3x squared. The squared came from subtracting 1 from the exponent, minus 2x to the first, because I brought that exponent down, minus, well, this is, the coefficient there is really 1, so minus 1, so plus 1 becomes 0. Okay, and I want to know when is it horizontal, so that means the derivative must equal 0, so I'm going to write 0 equals all that, and I should factor. So I'll go 3x and x, this has to be 1 and 1, let's try to get negative 2, that would be, if I have a minus 1 there for 3x, negative 3x plus 1x. So my answer is going to be x equals negative 1/3 or x equals 1. Those are the spots where the tangent line will be horizontal. All right. So on the next page, you'll notice a bunch of practice problems. So try those all out, and I will, and then you can check the answer key that's posted as well. After that, you can work on the homework, and then have a great weekend. Thanks. Bye.